Hello, today we'll be looking at Google CTF categories, KCONCAT, Writeup. Description says, as we are running our mitigated kernel, we safely implement a superfast text concatenation functionality directly in the kernel. Get root code and run cat flag. Note that the flag is 37805 long. The kernel module, the challenge implements a custom kernel module which has the following functionality. Exposes slash dev slash concat device with a concatenation service. It can concatenate multiple text segments and read the concatenated text. When you open the device, you can write text segments via write syscall into the device and use a predefined template via IOCTL 0x1234, which are stored under slash etc slash concat message template directory. There is an additional moderation feature IOCTL 0x1337, which delete, deletes all segments even from other devices and containing a specified blocked word. But this functionality only available with capsule segment. The segments are stored in the following structure. Hash define max message size 512, struct concat segment int is file, char message or file max message size. The is file field specifies whether the message or file field contains the full path of the template file under slash etc slash concat message template, not the message itself. To support the moderation feature, all open devices are stored in a linked list, and this list is prepared from a multi-threaded operation using mutex to only allow one thread to work on the structure. Define max segment 10 static struct mutex global mutex static struct list head after ds all descriptive struct fdinfo struct list head list struct mutex logs int is admin int segment count struct count segment star segments max segments. Kernel version. The challenge uses a customized kernel version which is based on the LTS 6.1.32 version, but adds our custom mitigation which tries to prevent the following exploitation technique as mentioned on our blog, where the mitigations are introduced: cross cache attack, elastic objects, free list corruption, out of bounds write on slab from one slab to another prevented by the guard pages. Vulnerabilities. There are few intentional vulnerabilities in the service. When the IOCTL is called, the process has captures admin capabilities and the device is put into administration mode, and further calls the device also become privileged. This is the program as you can pass the file descriptor to the setuid binary and it may call IOCTL on it, putting the into admin mode, and then the unprivileged process can also execute privileged functionalities, in this case the moderation function. The inspiration for this vulnerability was CD 2023-2002 Linux Bluetooth unauthorized management command execution. The moderation feature also locks the admin FD, contrary to other functionalities that modify the FDs segment and doesn't use the mutex for this access. This bug can be used to create a race condition between the write operation to read template file and moderation operation, which deletes the template structure causing a UAF. The race is seemingly tight as the moderation handles the template in four segments of I equal to 0 before deleting it k-free segment, and the read operation skips deleted segments, so we will need an extra trick to make the exploit reliable with the rate race. Additionally, the model does something risky. It shouldn't read files, driving nuts things you never should do in kernel explains this more detail. Okay. Exploitation. The exploit attached or as XPC does the following: creates a device used for moderation and when FT executes the slash user slash bin slash more security binary using admin underscore FT as TT out. This will trigger a TC gets IOCTL call to get the terminal properties, but it also puts the admin FT into admin mode. This enables calling moderation on the FT. Relaunch itself in a new user space where it has extra privileges. Mount slash etc slash concat slash message templates as tempfs, so we have full control over the template directly, which we would not able to modify outside the namespace. Creates a new template called delete this as a repo, which enables us to block the read operation executed by the kernel, so we can stop the kernel just as at the right point when the segment was not deleted yet. And the read operation is in progress, and at this point we can delete the segment causing UF and overwriting the memory of a newly allocated structure with the file's content which we control. Due to that we control the file. Leak kernel text addresses by bypass of KSLR by method described above. Create a device, add the template segment, delete this with points to the blocked FIFO pipe. Starts reading a new thread which blocks the kernel when it tries to read the template file backed by rpipe. Calls moderation function via admin FD to delete segment contains delete this. This also triggers if the file name contains a blocked word and frees the structure concat segment for our template. Creates a struct tty struct in the memory space. Use the struct concat underscore segment previously. Both are allocated from the kmalloc 1k cache. Write 0x14AAAs into the pipe which unblocks the kernel read operation, overrides TTY struct from offset 0x message or file field. When the 0x14As as the next TTY struct field at offset 0x18 is the struct TTY ops which contains the value PTM Unix 98 underscore off, which is a global variable that thus leaking the kernel address. Wait for the read thread to return and get the byte leak kernel pointer from the buffer. Create a fake struct TTY operations with the same method as above, just write the struct contents inside of is the only field set is TTY operations.ifetl, which is set to the address of prop return of point gadget of MOV dword pointer rdx which used by IOCTL in a 4 byte write-up. What were gadgets as we can control the both RDX and ECX via calling IOCTL. This also leaks the value of TTY operations of offset hex F8 which contains the owner address, so we can calculate the TTY struct's address easily too. The field struct mutex bin size mutex struct list head wait list struct list head next points to itself as there are no other elements in the list. Overrides the TTY struct with another fake struct TTY struct and sets it to struct TTY ops for a field to our previously allocated fake TTY operations, such achieving code execution by controlling the CTF calls. Overrides for pattern with then mod flag 0 via a 4 byte ARWIOCTL in multiple steps. Launch a new process which crashes itself by star and star 0 is equal to 0, triggering the overwritten for dump and that making slash flag readable for everyone. Cat the flag. Note on exploitation as machine is beginning the challenge users of the custom kernel and its extra mitigation added in this case. The mitigation did not protect us to exploit the vulnerability as vulnerability primitive was too strong, and it also allowed to easily find a well-known structure to be a structure of one page which could be freely overwritten. This weakness of mitigation is known as document mitigation weakness, but we expect real vulnerabilities harder to exploit would like collect some statistics in this, and we can help us proving a long plan for PNL CTF program which we pay 1, 2, 3, 5 for exploiting the external vulnerabilities and mitigation by functionality. When I say the flag is deliberately longer than cycle so you cannot override the template file name with via the UF and then use the FT security trick read the file by a privileged process. This was an unintended solution found by an internal test untested. And it adds on coding the kernel, own kernel CTF2 and get this at this location. Nice catch.